Let us now study about maximum power transfer in an alternating current circuit. As we know that average power consumption or average power transfer to an alternating current circuit we can write as P average is equals to E RMS I RMS cos phi, where phi is the phase difference between the variation of EMF and the current flowing through the circuit. Here we can write IRMS as ERMS by Z. So in this situation, average power can also be given as ERMS square by Z cos phi. Now in this situation, this is the average power we are having, and in parallel we can write the value of power consumed by individual circuit elements, like if Z is equals to R, that is for a pure resistance. If we calculate, we know for a pure resistance the value of phi is equals to 0 because current and EMF remain in same phase. This implies the average power consumption is ERMS multiplied by IRMS, or it can be written as ERMS square by R. Now similarly we can write if Z is equals to XL or XC, that is we are talking about for L and C, or L or C, we know the value of phi is equals to plus or minus pi by 2. Either current will be leading EMF or it will be lagging EMF. And in this situation, the value of cos phi is 0. That implies the average power consumption is equals to 0. So here we can write down a note which is quite useful for us, that is in AC circuits, inductors and capacitors never consume any average power. Here we are talking about per cycle. Average power is calculated per cycle or a long duration. In any alternating current circuit, inductors or capacitors never consume any average power, but due to the presence of inductor and capacitor, Z increases. So obviously the overall power decreases. So here we can write due to presence of L or C or both, overall current decreases and average power consumption also decreases. So we can directly state if current is decreasing, average power consumption will decrease, and due to L or C or both, the value of cos phi in the circuit will also be less than 1, due to which we can directly state in this situation what happens. Overall average power consumption decreases if L and C are present. And in any AC circuit we can directly state parasitic inductance and parasitic capacitances are always there, which are unwanted inductance and unwanted capacitance due to terminal effects in AC circuits. So always power consumption decrease due to L or C. But if L or C are adjusted to such a value that the effect of L and C are nullified, because these two behave oppositely as far as the phase variation of current with EMF is concerned. So these values are chosen in such a way that these two nullify each other, then the circuit impedance will be purely resistive, and we can say the average power consumption will be maximum. So we can directly write maximum power will be transferred in AC circuit when the impedance is purely resistive, and inductor and capacitance will nullify the effect of each other. In coming sections, we'll discuss the same in detail also.